Okay, number 13 says to simplify this very complicated looking problem with a whole bunch of exponents on it. We have 3 squared raised to the third power times 3 to the sixth power divided by 3 to the fourth power. So obviously the thing we need to know in this is all those properties of powers and how we can combine them and use them and simplify this. So it gives us 3 squared. It raises it again to the third power, multiplies it by 3 to the sixth power, and divides all of that by 3 to the fourth power. All right, so the first thing we need to know is what to do with this, the 3 squared raised to the third power. Well, this is the power of multiplying exponents, where if you have a power of a power, you multiply those two exponents. Now, I want to illustrate some of these properties just so that everybody understands what I'm talking about. If we have 3 squared, that's the same as saying 3 times 3. If we raise that to the third power, that's like saying that 3 more times. So 3 times 3 times 3 times 3 times 3 times 3. So that's 3 squared to the third power. Now, if we count how many 3's are multiplying here, we could just say there's 1, 2, 3, 4, 5, 6 3's, so 3 to the sixth power. Well, that's the same as saying 2 times 3. So that's why when we're multiplying when we're multiplying a base number, the 3, with a power to a power of a power, we simply multiply the powers and we get the actual simplified version. So that's what happens with this. And I'm going to erase my little example. Okay, so 3 to the squared power to the cubed power is going to be, like we said, 3 to the sixth power. Now, we're multiplying that by 3 to the sixth power again, and still dividing that by 3 to the fourth power. Now, we're still dealing with the numerator, the top numbers here. When we have base numbers multiplying with exponents, that's the additive property of exponents, and that's going to be adding the 6 and the 6 here. So again, let me illustrate why we're adding that. If we have 3 to the sixth power times 3 to the sixth power, that's like saying 3 to the 6, so I'm going to write 6 3's here. So 1, 2, 3, 4, 5, 6. That's the first 3 to the sixth power times, there's the multiplication, 3 to the sixth power again. So 3 times 3 times 3 times 3 times 3, and one more. All right, so now we have the 3 to the sixth power here times 3 to the sixth power here. Well, it's all just one line of multiplication. There's no change in an operation. So we just count how many 3's we've got. We've got 6 3's here. We've got 6 3's here. So that is the same as saying 3 to the 12th power, or 6 plus 6. All right, so that's why the additive property of exponents gets used. When we multiply base numbers, we add exponents. All right, so that's going to be 3 to the 12th power on the top divided by 3 to the fourth power. Okay, now when we're dividing base numbers with exponents, we simply subtract the exponents. This is the opposite of multiplying base numbers with exponents. So if we multiply and add the exponents, we divide and subtract the exponents. And again, very quickly, I'm just going to illustrate why that is. The 3 to the 12th power on the top, well, I know this is going to take me a minute here, but I'm going to write 3 to the 12th power here. Okay, so I'm multiplying all of these 3's And this is the long version of 3 to the 12th power. I have 12 threes here. And that's being divided by 3 to the 4th power. It's a little bit quicker to do this one. All right. Now, as you should know, if we have multiplication and division of the same number happening, we can start canceling things out. So I can cancel out every 3. For every 3 on top, I can cancel out 1 3 on the bottom. Now, that means I canceled these 4 and these 4, leaving these 8 at the top. So that's going to be 3 to the 8th power. Well, that's the same as saying 12 minus 4. So 3 to the 8th power is our final answer if we say 3 to the 12th minus 3 to the 4th. That's it.